All right, so let's go to our first page of notes. We're going to review through our laws of exponents, and then we're going to deal a little bit with our scientific notation. And then once we're done with those, we're going to go into our new thing for today, which is your fractional exponents. So our multiplication rule. So if we have two variables that we are multiplying, what do we do with those exponents? Add them. So this would become x to the a plus b. And a and b, they just represent numbers. So you would just add those exponents together. So this also applies, however, if your base is a number, like for example 3 to the second times 3 to the fourth, you don't change your 3, which a lot of people tend to forget. They tend to multiply those and tell me it's a 9. No. It's still a 3. It's going to stay as a 3, and then you add your exponent, so that becomes 3 to the 6th. So that base, whatever the exponent's attached to, stays as it is. Add those exponents. Then you can't do it. Okay? Division rule. What do we do with our exponents for division? We subtract them. Always top minus bottom. So this would become x to the a minus b. Next one, our power law. A lot of teachers tend to refer to as the power to power rule. Because you have two exponents, you have an exponent that is raised to yet another exponent. So that's why it's power to a power. Does anybody remember what we do with those ones? Multiply them. So this would become x to the a times c. So now some people get a little confused. If you have more than one thing in a parenthesis, keep in mind these are both raised to the first power. Remember, there's no number written. It's still the first power. But that a is going to go to both parts of it. So it's going to become x to the a, because 1 times a is a, and y to the a. So again, 1 times a is a. So that exponent on the outside goes to everything on the inside. Even if we have a coefficient in there. So if we got this coefficient of 2, this exponent of 4 on the outside also goes to the 2. And then 4 times 3 makes that x to the 12. And then 2 to the 4th is 4, 8, 16. So that becomes 16x to the 12. So that exponent goes to everything, coefficients and letters. And then same thing also for division. If you have two things being divided, that exponent on the outside is going to go to both of them. So x to the a over y to the a. So anything inside that parentheses gets that exponent. So 0 exponents, anything to the 0 power is 1. Anything to the 0 is 1. Now you have to be careful. If we have parentheses, like that, 6x in parentheses to the 0, that whole thing turns into a 1. If there aren't parentheses, so let's say I have 6x to the 0, no parentheses, the only thing the 0 is attached to is the x. So the x turns into a 1. And then it's times the 6 out in front of it. So you have to pay attention. If there's parentheses, if there's not parentheses, it does change the answer up. And then our last one, negative exponents. We can never leave them as negative exponents, so how do we make it positive? You have to move it down to the bottom of the fraction. Remember, everything is a fraction. Everything is over a 1. We don't always write the 1 because we do get a little bit lazy. So that x would move down to the bottom and it would become a positive a now. So once you've moved it, it becomes positive. Questions on our exponents rules? Hopefully some of them at least are familiar. Scientific notation next. We use scientific notation a lot in science class, hence the name scientific notation. So it's just a method of writing numbers by using powers of 10. And so what it does is when you have extremely large numbers or extremely large decimals, writing them instead of as powers of tens, it just makes it easier to be able to do your calculations with them. So our scientific notation is in the form of a times 10 to the b. So a represents a number, b represents a number, and you've got that 10 times something in there. So a is between 1 and 10. And b is an integer. So your exponent can never be a decimal or a fraction or anything. Your exponent's always going to be an integer value. Whether it's positive or negative, it's always going to be an integer. So let's take a look at our powers of 10. So 10 to the fourth means that we have 4 zeros there. So 10 to the fourth is really 10,000. 10 to the third would be 1,000. That means there's 3 zeros. 10 squared is what? 100. 10 to the first. And then 1. Anything to the 0 is always a 1. So whenever you're multiplying by a base 10 with a positive exponent, the number is going to get larger, and the decimal point moves to the right. So if you're multiplying by a 10 that has a positive exponent, that means your number is just going to get larger. You move the decimal to the right to make it larger. So then going the other way, 10 to the negative 1 is really 1 over 10, which as a decimal would be 0.1. 1/10. Now, this one would be over 100. The decimal would be 0.01. Next one is 1,000. 0.001. And then this one's over 10,000. 0.0001. So when you multiply by a base 10 with a negative exponent, your number gets smaller, and the decimal is going to move to the left. All right, so we're going to do some practice problems using our scientific notation. So number 1, we're going to write that decimal in scientific notation. So we want the decimal to end up right there in between the 5 and the 4. That's where we want the decimal to be. You don't want the decimal to be here because that's not a number between 1 and 10. That's a number less than 1. And you don't want the decimal to be here because then that's greater than 10. It has to be in between 1 and 10. So that's why we want the decimal to be right there. So what we have to do is we have to figure out how many times did we move that decimal to get it to be where we want it to be. So we did 1, 2, 3, 4, 5, 6. And because it was a very large decimal to begin with, that tells me it was a negative 6. Negative goes with the decimals. So number 2, we are going to change this one to be an ordinary decimal notation. So how many times am I moving it? 5. And as I said on the front, it's going to get larger and you're going to move it to the right. So we're going to move it 1, 2, 3, 4, 5. What do we fill those spaces in with? Zeros. Yeah, you guys remember. So 541,000. All right, what would be our exponent on the 10 here for this decimal? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, you got to get in between the 8 and the 2. So you'd have to move it 9 times. So n would be negative 9. Because it was such a large decimal, that's always negative. That. So like, let's say I had 8,000, let's say that was my number. Not a large decimal. So this would be 8.2 times 10, and this would be a positive exponent. 1, 2, 3, 4. So when you've got the decimal and then all these zeros, that's your hint. It's going to be a negative. So let's do some operations with these. Now these operations are actually pretty simple. We're going to multiply the numbers out in front just like we would any coefficient. So what's 1.5 times 3? 4.5. And then as we just said on the front, we're multiplying tens. So what do we do with those exponents? Add them. So what's negative 4 plus 6? 2. There you go, done. I multiplied them. What? No. Number 5. Let's divide. 2 divided by 8 is going to give us a decimal. Nope. 0.25. Now, again, dividing. So what do we do with those exponents? Subtract. So what's 3 minus 8? Negative 5. Now, we have to check. Is this what it should look like for scientific notation there? The decimal should be 2.5 in the front. 0.25 is less than 1. It has to be between 1 and 10. So I moved my decimal over. So that's going to make it negative 6. I had to move that decimal one more time over to the right, just like we did up here. So that's why I went from negative 5 to negative 6. All right, number 6. Let's multiply the top. So 7.5 times 2.8. 7.5 times 2.8, 21. Add our exponents. 5 plus negative 8, negative 3. All right, so now we do our division. So now 21 divided by 1.5. 14. Division, subtracting our exponents. So negative 3 minus negative 5. Yep. Because when you subtract a negative, it makes a positive. Now, is that acceptable though? No. It's got to be 1.4. So I moved my decimal left, so that exponent's going to get larger. So 1.4 times 10 to the third. So a fractional exponent is an exponent that can be expressed as m over n. And so what happens is m is your power, n is your root. So power deals with your exponents. Roots, that goes back to what we did a few units ago. You have your square root, cube root, fourth root, fifth root. So it's the opposite of an exponent. So the exponent 1 over n indicates the nth root, and the exponent m over n indicates the nth root raised to the nth power. So what happens is, let's look at this one first. The top part of that fraction is your power. The bottom part is your root. So the bottom number goes in front of that radical sign. That's your root. And then your power is your exponent that it gets raised to afterwards. It's not that bad. As we do examples, I promise, it will be fine. So then the one up above, again, it's power over root. So nth root, and it's raised to an exponent of 1, which really exponent of 1 means it doesn't change. It's just the way it is. So let's take a look at our examples here. So 7, we are going to just rewrite each expression in radical form, and then we're going to simplify. So again, this top one is your power. Bottom one is our root. So we're finding the second root, also known as the square root, of 49 to the first power. So that is 7. So we're going to go to letter C next. I'm going to do B actually last here. So we have the third root of negative 125, and then it's to the second power. So do you guys remember how to get third root in your calculator? If you push math, and then you go to option 4, that's your third root, negative 125, and then you go on the outside and you square it. So you end up with 25. Yeah, but it's going to tell you to set it up in the radical form, so you still have to remember how to set it up, but then you can type it in your calculator, yes. So this one, third root of 24 to the fourth power. So go ahead, type that one in. That's going to get us a decimal. What comes after the 7? So 2 to 8, I'll round off to. So looking at letter B, we have an addition of the negative there. What does the negative do again? Means we have to move it to the bottom of a fraction. So now it turns positive once I've done that. So take care of the negative first. And now we can do like we did the other ones. This is going to be the fifth root of 32, and it would be to the first power. So what is the fifth root of 32? It is 2. You guys know how to do that in your calculator? So we want to find fifth root. So I'm going to type in the number 5 first. And then if you go to your math button right there, it's got the X root under choice number 5. So you'll select that. And then as you can see, it turned it into the fifth root in the calculator. And then you type in your 32. Then you get 2. So 1 over 2. So number 8, we're going to go backwards. We have the radicals. We're going to write them as the fractional exponents. So for letter A, what is our power? It's not written, but our power would be 1. So this becomes 19 to the 1/3, power over root. So letter B, what would this be as a fractional exponent? X to the 1/6. C would be 81 to the 3/4. Now for letter D, you have 3 different parts there. You got the 12, you got the x cubed, and you got the y to the 8th. So you have to do each one separately. So right now this is 12 to the first power. This would become 12. What is that number? I can't read it. Okay. 12 to the 1/4. Okay, so 12 to the 1/4, and then x to the 3/4, power over root. Y to the 8/4, which 8 divided by 4 is 2, so it becomes y squared. No, you always have to simplify. So you would have to simplify to the 2. Yes. All right, number 9, we are simplifying, but first we have a power raised to another power, so we have to multiply those. With fractions, you multiply your tops, so 1 times 1 gives me a 1, and then you multiply your denominators, so 2 times 3 gives me a 6. Well, no, we're not done simplifying. So we got to find the 6th root of 64. So in our calculator, you would hit 6, math, and then we would go to choice 5, and again, the calculator then turns it into the 6th root of 64. We get 2. 2 is our answer. So then our last thing for today, sometimes you have to plug values in, and then you've got your fractional exponents to take care of. So here we plug in a 9, so we get 36 times 9 to the negative 1/2. So again, that negative exponent means this is really 1 over 9 to the 1/2, which is really the square root of 9. So what is the square root of 9? So this is 36 times 1/3, which is, use calculator, 12. So B, we're going to plug in an 8. We got 8 to the 0 plus 8 to the 1/3 plus 8 to the negative 2. So plugging in 8 first for all of our A's. So a to the 0 is 1. 8 to the 1/3 really means I'm taking the cube root of 8, which is 2. And then 8 to the negative 2 is 1 over 8 squared. Which, what is 8 squared? That's 1 over 64. So adding those together, you can use a calculator if you're not good with fractions. (193 over 64). 1 plus 2 plus 1 over 64. 193 over 64. All right, 2 more examples. Okay. So same thing, it's just this time they've written it in function notation. So here we're plugging in a 2. So like we were doing the other ones, negative exponent means it's really a fraction. And then plus 1, anything to the 0 is 1. So what is 2 squared? 1 over 4 plus 1, so that's 1.25 or 5/4. So number 2, just to kind of review our compositions also. Remember, you always start with the one closest to the number, so we're going to start with f of 0. You got it, Tony? So if I plug in a 0 for my x, that means I'm doing 1/2 to the 0, which is what? 1. So now you take this answer and you plug it into the g function this time. So 1 plus 1 to the -3. So what is 1 plus 1? 2. Negative exponent means we have a fraction. 1/2 to the +3. And what is 2 to the 3rd power?